Should we be starting already?
Good morning, everybody. It's great to have you all together here for another webinar. And while we are, we should have the videos of Dion and Peter off. I will start sharing my screen, and so in order to take you through a brief introduction. This webinar comes in a line of several other webinars, one held earlier this year and some last year, of the China-Europe Water Platform, where we are examining the water market and technology opportunities. We're doing that both to showcase which solutions are available, inspiring for new market opportunities, inspiring for relation building. We're doing that in order to showcase what technologies can offer with regard to contributing to the challenges. And we're also doing that to showcase interesting and inspiring market approaches. At our last meeting, we had a discussion which looked like that there was some perceptions that some of the draft policy recommendations, which I will come back to, was favoring market economy. That's absolutely not the case. So just to get these things right from the start, I will in a few minutes say a few words about the market, what is actually meant by that. I'll go through the program very quickly. We have a series of very interesting speakers, and I'll present you with some of the key questions which will be discussed later at the roundtable. A few words again about the China water market and technology outlook developed by the CWP. That is an overview of existing market prognosis, of technology perspectives, and again the draft policy recommendations. That report was made for 2021, and a new one will be made for 2022, following the webinars and the physical side events, which you will be invited to join later this year in Shanghai, Jiangxi, and Copenhagen. But first of all, the market in a nutshell. The Chinese market is expected to become the world's largest in 2025. The market is strongly driven by government targets, also by some industry perspectives, but it's very much driven by regulatory targets set up in the 14th five-year plan and other specific action plans. But it's also a market which show huge geographical differences with regard to the water challenges listed. All of that is what the China market report is about. But when it comes to defining the market, here we understand that whether investments are driven by government initiatives or by industry initiatives or other type of steps, the market is the place where these investments eventually turns into procurement of technologies and subsequently implementation. And that is, of course, therefore it's interesting to discuss and review where do we actually find the market. And how does it work? How is it defined? What are the standards defining a market eventually? Because this is also what we will have to live with in the many years to come. Whatever type of solutions are procured within the water sector, the lifespan of these, particularly the hardware, the lifespan of these may be measured in 10, 20 or 30 or even 50 years of lifespan time. So the quality of the product therefore also determines what type of value will be possible for society, industries and citizens. And that also means that a market which invests in the very, very best solutions might get the best long-term value. But a market which, for various reasons, either don't require it or can't afford it, or because of financing problems, will have to live with technologies which may not necessarily, as just one example, mean that they are energy efficient and hereby instead contribute to climate change. And that means what we will see is that there are many different approaches to a market, and there are very different there are many success stories of approaching a market, whether it is asking quality at one level or another one. But at the end of the day, this is also a matter of that the water sector needs to give its contribution to reducing the drivers of climate change. The water sector should look into the possibilities coming from digitalization. The water sector will inevitably have to be driven by a circular economy approach. But if the market, the place where standards may be not up to date with what solutions can offer, will not change investments driven by very inspiring and high-ranked government targets. But if these standards don't translate into the new solutions, we may have a situation, example giving, in the wastewater sector, where new investments may lead to cleaner water, but they are energy consuming and will lead to climate change. So that's just to give a small frame for the discussion. Our program, we will start out with Ms. Wu Xiaomei from the IWHR, who will speak about achievements, experience, and challenges of rural water supply in China. And we will also have a special setting the scene speech from Ms. Tia Savolainen from Sweco, Finland, who will present the main results of a white paper, Small-Scale Water Supply and Sanitation in Rural Areas, a circular economy perspective laid down on solutions in Europe. We will then look into a number of company presentations, and here there will be very interesting voices from Ms. Fenyuan Hu from Niras, Denmark, Mr. Luca Bovo Sommer of Austria, Herbert Chan from Uros, Finland, Mr. Bruno Lopiteau from Sewage, France, and Ms. Jingjing Ma, Nordic Group, China. And finally, nature-based solutions by Mr. Peter Gregerson from the Center for Recycling and Mr. Dion van Wachon from Rietland, from Belgium. And finally, Mr. Liam Jia from the USME Center and myself will give a few closing words after we have had the roundtable. So the key questions for this webinar will also be, to which extent does the water market request energy efficiency? Does it request the possibilities laid down with digitalization? And does it ensure long-term economic and environmental value to society? Is the market in rural areas based on one-size-fits-all approach, formulated in inflexible standards, or is it open for customized solutions? Behind this question is that when we moved here from the very general context of urban water into rural water, we also moved to small, medium cities and villages, which may not be part of a very professional water in professional environment. We may be in very local circumstances. We may be far away from the universities and other science-based approaches. And we may have situations where there might not be technicians available in all places, and where ambitions about customized solutions may be difficult and instead a one-size-fits-all is necessary. But anyhow, what are our observations? And following that one, standards defining content of tenders. Are they up to date with technology opportunities or lagging behind? It may sound like a question which can even be understood maybe as a bit rude, but it is a way to ensure that the investments laid down in ambitious government goals actually also in the end leads to the optimal value for society. So, is there a tangible benefit to society if choosing the often costlier state-of-the-art solutions? In the draft market report I mentioned earlier, there were a number of policy recommendations. I will not go so much into these, but I'll just invite you to join the reading when we have the new draft ready in a couple of months and to provide your feedback. With this, I will stop sharing my screen and invite Ms. Wu Xiaomei to take the floor. And for that, I will also invite all English speakers to select the English channel for translation services. Thank you. Ms. Wu Xiaomei, the floor is yours.
好的 ，Yes， 谢谢主持人。然后我很高兴今天有这个机会跟大家分享，就是关于中国农村供水的一些取得的成就经验，以及面临的挑战和“十四五”总备做的一些目标主要任务。可能跟刚才主持人最初介绍的那个题目有所出入，但是因为我主要是从事农村供水的这个工作，所以还是介绍农村供水的一些相关工作。那我这个报告呢分为4个部分，首先就是我们介绍一下农村供水的一个现状的情况。Sorry， 我这个 PPT 有点问题啊。不好意思，我现在开始。然后我们接着介绍就中国农村的供水现状。那首先我给大家简要介绍一下我们农村供水的一个发展历程。那是1949年新中国成立之后呢，中国是先后结合，就是在49到79年之间是结合农田水利工程建设来通过解决水源解决了部分农村供水的问题。然后从1979年到1999年这个阶段，80年到1999年这个阶段是通过实行防病改水，主要针对饮水用负超标等一些问题的解决，来解决了一部分农村饮水安全问题。然后在2000年到2004年是实施饮水解困项目，解决了一部分农村的饮水困难的问题。然后从2005年到到2020年是通过了3个5年计划。包括农村饮水安全工程以及农村饮水安全巩固提升这个工程的一个规划的一个实施，从全面解决了就是中国的农村饮水安全问题，在这个方面还是取得了一个非常大的成就，后面会进一步的详细介绍。那从我们国的现状来看呢，到2021年底，就是我们全国已经形成了较为完整的中国的农村的供水工程体系已经基本建成。目前2021年底我国是有农村供水工程827万处，那可服务的农村人口是9.09亿。那这一个是包括了农村的常住人口，还有一些就是虽然不常住在农村，但是由于节假日会返回农村的这部分户籍人口，所以这个数量还是比我们的通常常住人口会多一点。 然后在这个工程里面，827万处工程里面有相当大数量的是分散式供水工程，但是分散式工程的虽然数量多，但它服务人口是比较低的。那我们这里面有一个给出一个数据是，规模化供水工程服务农村人口的比例是达到52%，就是1000吨万人，就是我们说的这么一个规模。还有就是城市管网延伸，就城乡供水一体化的供水工程的人口比例达52%，所以总体来说是以集中供水工程为主的这么一个工程的供水一个体系。那有2个数据，一个是我国从农村集中供水率是从2004年的38%提升到2021年是89%，就是我们全国有89%的农村人口是通过集中式供水工程来提供供水。那我们一个自来水普及率呢，是从2004年的36%提升到2021年的84%这么一个比例。那第2个就是我们说是按照我们的现行的饮水安全评价的标准来说呢，我国是已经全面解决了农村人口特别是贫困人口的饮水安全问题。那主要是我们在“十三五”期间中央资金以及地方的各级资金总共投入了有2093亿，其中中央补助资金是296.06亿。那我们在这个期间通过“十三五”的5年规划，我们是总共提升了2.7亿农村人口的饮水安全水平，其中包括了贫困人口是1710万，饮水型负超标人口是975万，苦咸水人口是125万。那这一个完成的这个目标是已经超过了我们“十三五”的规划的一个既定的目标。第2部分就说一下我们农村供水，就是特别是饮水安全工程以来取得的一些成就。第1个方面就是我们是农村饮水安全问题已经基本得到了一个全面的解决。那在说我们广大的农民群众已经喝上了放心水，前面已经说到通过我们饮水安全工程的一个实施，解决了我们国家的绝大多数农民的一个饮水安全问题。第2个还有个数据呢，给各位嘉宾汇报一下，就是我们在2019年，就中国已经提前6年，就是通过我们饮水安全工程的一个规划的一个实施，解决了实现了联合国的1000年的水与卫生的一个发展目标。第2点就是我们是大力推动了城乡居民的基本公共服务的均等化，因为通过我们看到我们的规模化供水人口的一个覆盖比例52%，然后我们的这个就包括城乡一体供水和规模化供水，那它的与农村与城市在水质、水量以及供水服务上都享受到了同等的一个水平。第3点是有效保证了农村群众的一个健康水平，提高了生活质量。那包括前面提到的，就是我国的农村的饮水型负超标和苦咸水的问题得到了妥善解决，还是对于改善一些包括腹斑芽呀、腹股症啊，以及一些胃肠道疾病等等的这些影响群众健康的这些问题，还是得到一个解决。那这一个照片也充分显示了2代人，就是父亲这一代是饮用了高腹水，他有腹斑芽的这个情况。那孩子这一代，由于我们解决这个腹超标的这个问题，看他的牙齿是非常健康的。然后第3个就是显著改善了农村的人居环境，助力了美丽乡村建设。由于我们农村供水工程的一个基础设施的完成，对于我们的一些改测，包括它的卫生、洗浴、淋浴条件的改善，那包括一些庭院经济的发展，都有助于我们农村美丽乡村的一个建设和发展。最后也是对于促进，就是我们因为中国是一个各民族非常有56个民族的一个国家，那对于促进民族团结、维护社会和谐稳定，也是起到了一个非常好的一个作用。那第3个部分呢，主要介绍一下我们中国在农村供水方面的一些主要的一些经验做法。第1点就是科学的编制规划。政府主导来推动这个农村饮水安全工作的一个实施。那这个主要是有2个给大家介绍一下。第1个就是我们中国的国务院是先后批准的实施的，就是2005到06年的农村饮水安全应急工程规划，还有“11.5”规划以及“12.5”规划。还有就是我们这个都对我们实施相关的一个项目的推动，解决农村饮水安全问题，就起到了一个从顶层设计到科学编制、政府主动推导的这么一个好的一个 实施的一个作用。第二个就是我们在“15”期间呢，是虽然从全国层面没有编制规划，但是各省是编制了农村饮水安全巩固提升的规划，并经过省级人民政府的批准后，也是在全国各地进行了一个全国范围的一个开展实施。第二个就是我们在那个规划实施以及我们在这个推动农村饮水工作的时候，我们也充分考虑到了就中国的一个区域的差别，实行差异化的投资政策。那这个投资政策呢，重点是向就是中西部的，就是经济相较东部更落后的，就是我们的少数民族边疆地区以及经济欠发达的中西部的省份来进行倾斜。那这边有3个数据给大家提供。第一个就是我们在2005到2015年的农村饮水安全工程和巩固提升工程的这规划实施期间，我们是有88.89%的中央的资金是用于支持中西部地区，那在45.94%的中央资金是用于支持西部地区，所以这一个是我们就体现了，就我们重点是向少数民族和边疆地区的来进行倾斜。然后第三个数据呢是2016年到2020年期间，就是我国的“15”规划期间是聚焦脱贫攻坚，那其中的59.55%的中央资金是用于补助了西部地区。第3个那个主要经验做法就是我们严格项目的建设管理，推行用水户的全过程参与，包括了规范工程的农村供水工程的建设，确保建一处成一处，发挥效益一处。另外呢，也是推行了我们的农民用水户全过程的参与，包括从我们的就是是否要建，然后怎么建，建好之后怎么管，赋予了用水户的一个知情权、参与权和监督权，也增强了农民用水户的这么一个责任感。那第4呢，就是我们是包括了强化运行管护，就是促进工程长效。这个主要是第一个是在2019年底，我们推行建立的3个责任，就是建立了管理责任体系，包括政府的主体责任，然后行业部门的监管责任和运行管理单位的具体的运行管理责任。那第二是我们就是建立了从2019年开始建立了这个工程的维修养护的中央财政的补助机制。那这一个就是我们从19年的14.5亿到2020年的25亿到2021年的28亿，是一个逐步增高的一个就是帮助我们的农村供水工程的一个正常运行的一个维修养护的资金的这么一个政策。然后第3个是加快建立了合理水价水费机制，以水费收缴来促进工程良性运行，那也从工程的自身能够实现它的一个良性运行进行的一个相关的工作。最后一个就是我们强化了行业监管，及时发现和解决问题。那体现在就是以下几点，就第一点是我们建立了常态化的监督检查工作机制，开展了大规模的暗访。那比如像我们2019年开展了全国3000个村的一个农村饮水安全工作的暗访工作。第二个就是开通了水利部的12314以及省市县级的农村饮水举报监督电话。那这个也是通过就是我们的农民用水户如果有什么问题，当地的工程管理人员不能解决的话，可以通过每一级的逐级的这个举报电话来反映问题，来得到这个问题的一个解决。那也通过通过这些监督举报电话的建立，那我们这也是建立了一个问题清单和整改台账，来保证问题能够及时的得到解决。那最后说一下，就是我们在农村供水上面临的一些挑战，以及“15”农村供水保障规划的一些目标和那个主要任务。那首先虽然我们前面取得了这些成绩，那要看到我们中国农村的保障水平还是相对来说可能跟一些其他的一些发达国家还是有一定的差距，那总体还是处于一个初级的一个发展阶段。那主要有几个 问题啊。第一个就是我们的区域发展差异性很大，我们的东部地区水资源条件丰富，然后经济发展比较高呢，城乡一体化水平比较好，但有这些中西部地区呢，由于水资源的经济发展的问题、建设和管理问题，那它的一个发展水平还处于一个偏低的一个情况，那整个区域差异性比较大。第二个是我们仍有部分工程，就是特别是在中西部地区还存在一些水源不稳定，特别是小型水源的，还有工程的早期工程的老化，以及小型供水工程管理不到位等等问题，所以还有一些农村供水的问题。那总的来说，就是我国的农村供水的保障的一个整体水平仍然需要持续的提升。第二个方面呢，就是我们农村居民的需求也是在不断增加的。第一个是在社会经济发展的情况，这个条件下，那农村居民他的一个对用水量的需求，以及对水质的需求的，也是有了一个更高层次的一个需求。第二个就是在乡村振兴的这个我国的一个战略的实施下，那农村的二三产业，就除了农村居民的生活用水，二三产业的用水需求也在增加。第三点就是供水的标准的一个提升。像我们今年刚发布的生活用水卫生标准，就国标574就2002的这一个发布呢，那对有些农村供水的一个水质的标准也有所提升，所以这样也对我们农村供水提出了一个更高的一个要求。那在这个背景下，我们也是开展了“14·5”农村供水保障规划的实施。那这个规划是在2021年9月13日由中国水利部印发，对我国的农村“14·5”农村供水保障工作进行了一个系统的部署和全面的安排。那这个规划的主要目标，有3个。我归纳了一下，第一个就是农村的自来水普及率要提升到88%，就是从我们2020年的83%提升到88%。第二点就是要完善农村供水长效运行管理体制机制，就包括我们进一步完善我们的管理责任体系，包括健全我们的水价水费的体系，以及还有我们的专业化管护水平的这么一个能力的提升。第三点就是我们要进一步提高农村供水的水质保障水平，那包括我们的水源保护，水源的保护的这个水平的这个提升，还有就是我们要配套完善农村供水工程的净化消毒设施设备，还有就是我们要加强水质的一个在线的检测与监测的这么一个情况。那在“14·5”规划的我们主要的任务也是跟我们的目标去契合的。第一个就是我们要加强水源工程的建设和保护。那这个水源呢，主要是我们要是一些利用已有的骨干水源和那个就大型引调水以及水库水。那我们对一些像西南地区会建设一些有条件的地区建设一些小型水库啊、山平塘啊等等，来提升他们的水源保障水平。因为我们要加强水源的保护。第二个就是我们要建设一批规模化供水工程。那这个规模化供水工程呢，就是有条件的东部地区，像有一些江苏、浙江等省份要实现了全面的，包括福建全面的城乡一体化供水，还有我们其他有条件的中西部地区呢，那是我们也是能实现城乡一体化就实现城乡一体化，不能实现城乡一体化的话，我们在尽可能的条件下能够推进就是规模化供水工程的一个建设。第三个就是我们要建设一批标准化的农村供水工程。那这个包括我们的水源稳定水源的选择建设，包括我们的净化消毒设施设备的配套完善，包括我们的一些管网的规范化标准化建设，来提升小型供水工程的建设标准。第三个就是我们要改造和维护一批就是老化失修的农村供水工程，来提升改善现有的农村供水工程的一个建设和管理水平。最后我们还是要对一些软件上面运行管理水平上面进行提升，包括就是我们第一个就是我们前面说到的，我们完善农村供水工程的一个责任体系进一步落实，还有我们创新就是不同类型的农村供水工程的一个工程管护的一个模式要大力推行就是专业化管理。第三个就是要加强农村一个产权的一个制度的一个改革。第四个就是还要进一步完善水价水费合理水价的形成机制和水费的收缴机制。第五就是我们要健全就是工程建设和改造包括这部分的一个投融资的机制。 第6点就是要加强专业化人才队伍的一个建设。最后我们也要提升就是农村供水工程的一个信息化的管理水平，来进一步就是推进我们农村供水保障水平的一个提升，来完成我们的“14-5”的规划一个目标的一个实现。好，我的分享就到这里，谢谢。
Thank you very much, Ms. Wu Xiaomei. It is indeed impressive results you have made with supplying water to the rural population and reach the SDG targets 6 years in advance. Very, very impressive. This presentation could lead to a lot of questions. Regrettably, our meeting format doesn't allow for that, but I'll suggest a couple of things. First, you're welcome to put up questions in the chat. You are very welcome to provide your questions and feedback also to me afterwards, because I'm quite sure we will have future CWP events which will we should look much more into the details here and how we can discuss not least the challenges. But thank you very much, Ms. Wu Xiaomei. It was a pleasure to follow your presentation. Unfortunately, I took a lot of time, too much for my own introduction, so I hope our coming speakers will help me with catching up with the timetable, and also immediately rush to give the floor to Ms. Tia Savolainen from Sweco in Finland. Please go ahead, Tia.
Thank you. Right, now you should see my screen. Yes, hello, and thank you for coming here today. I am Tia Savolainen from a company called Sweco. I am located up in the north, as I am in Finland. I'll give you a white paper presentation as a start of discussion. And the white paper is written for the Finnish Center for Economic Development, Transport and the Environment. And the topic is small-scale water supply and sanitation in rural areas. But first, let me introduce the company Sweco I am from. Sweco is Europe's leading architecture and engineering consultancy, and we have 17,500 full-time employees. Our net sales are over 20 billion Swedish crowns, and we act in 14 European markets and in more than 70 markets worldwide. Sweco is Europe's leading architecture and engineering consultancy because we are located locally, but we have a global expertise. And for example, we plan buildings and urban districts. We can be consulted on the themes of water, energy, and environment. We also plan transportation. It may be from cycling to rail-bound traffic. But now about the white paper, it discusses the circular economy of small-scale water supply and sanitation in Europe. It identifies and highlights their circular economy practices and technologies in use or under development. Here is a map about rural areas in Europe. It's a bit old, but still the green color indicates rural areas. And as you can see, we have a lot of rural areas that need water supply and sanitation technologies here in Europe. The main focus in the water supply and sanitation is to take advantage of the concept of circular economy. Instead of linear take, make, and waste model, circular economy is circular and ongoing. Their waste and usage of materials are reduced and then reused again after the materials are recycled to a new function. After it, the materials can be restored and recovered. And then a really short introduction to the history of the water supply in rural Europe. Well, it all began at the start of agriculture. During the Bronze Age, there were on modern day Crete and the Indus Valley, there were already aqueducts and cisterns and filtering systems, etc. And also, it has been common to use sludge as a fertilizer. However, the usage has been hindered a bit because of the legislation. And then this chapter will discuss the drinking water production technologies in use in small-scale rural areas. Usually the water supply is organized either with private wells or community or publicly managed supplies. Private or individual wells are point sources, such as boreholes, duck wells, springs, or rainwater collections, and they are piped into the dwelling or yard and serve a single family or just a small number of households, like farms or hamlets. And mainly they are operated by the users themselves. Community managed supplies are managed by the community members, and they are also the users of the water. And they can vary from point sources from which community members collect the water and carry it home, or to systems that may involve treatment and storage and piping to distribution. And public supplies, well, they are managed by a distinct public entity, such as municipality or water board association. And they are located spatially on limited areas, like small municipalities or towns. Then here are the sources for drinking water that are used. They are groundwater, freshwater, brackish water, and seawater. And the treatment method itself is chosen depending on how the water quality needs to be improved. And here are the technologies in use for drinking water production. Sand filtration, oxidation, coagulation, active carbon adsorption, ozonation, chlorination, alkalization, and UV disinfection can be used. Sand filtration, of course, removes solids and organisms, and if it is used with oxidation, it also removes iron and manganese. Oxidation also removes radon and hydrogen sulfides. Coagulation removes solids such as sand or algae, also iron and protozoa. Active carbon adsorption removes radon and color, pesticides, smells and taste, etc. And ozonization can remove biofilms and algae, microorganisms and such. Chlorination also removes microbes, and alkalization, it raises the pH, but also captures free carbon dioxide. And of course, UV disinfection removes microbes. So this was in short about the drinking water, and now this chapter will discuss the sewage treatment technologies that are in use in small scale in rural areas. Well, there are two types of wastewater. The sewage can be separated to grey and black waters. Grey water is domestic wastewater, which is produced from the recycling of laundry, shower, or hand basin water. And black water, well, it is sewage, which also contains the discharge from toilets. So it contains more organic loading than the grey water. And here are some of the treatment technologies in use in Europe. All small-scale treatment technologies have some sort of a septic tank as a first stage of the treatment, and it separates solids and grease. Grey and black waters can be both treated with ground absorption and filtration. They are both subsurface disposal systems, and the sewage is either absorbed or filtrated to the ground. In the ground absorption, the natural or artificial soil purifies the sewage, and the treated sewage ends up in the groundwater. In ground filtration, the treated sewage is collected and discarded to a water body. The ground treatment plant requires a dephosphorization if it treats black waters. Grey water can be processed in a seepage pit or with a filter. The seepage pit should be used only in specific cases, and it can be used only for small amounts of grey water. The grey water filter, it may use either a filter bag or a lime filter and sedimentation to remove impurities. And there are multiple different grey water filters in the market. The black water sewage can be treated in small-scale treatment plants or with a reed field. The treatment plants are electrical devices based on biological and chemical treatment. There are, again, plenty of devices, different devices on the market. Constructed reed fields or other wetlands are also a form of biological treatment. Here are pictures of reed fields or wetlands. I think you will hear more about them later today, but in reed fields or wetlands, the sewage is treated by bacteria, and the bacteria forms a biofilm on plant roots and clay granules. Yes, so the summary, to summarize, there are multiple different technologies to be utilized. They are already on the market. And about the white paper itself, it will be published on the CWP site later. Yes, thank you. As I said before, I'm Tia Savolainen. I'm from Sweco and from Finland, and I thank you.
Thank you very much, Tia. Just one quick question. Do you have an assessment of when the white paper will be available for download from the website?
I think we agreed that we will send it to the center at the end of this month, and they will send it to you after this.
Okay, so in a couple of weeks. Thank you very much, Tia, and looking forward to receiving the report and making it available. Without further ado, I will invite Ms. Fenhuan Hu to take the floor.
Yes, I will now share my screen.大家好，非常感谢中欧水平台提供此次机会，向大家介绍本人自2012年以来作为主要研发人员开发的一套湖泊生态模型。众所周知呢，数学模型呢是为科学管理提供可靠依据的最佳工具。那么湖泊生态模型呢，也是湖库、水质、水生态管理的有力工具。对于我国大多数的中小型城市和通向自来 Sorry. Yeah.
Fen?
Yes.
Your presentation is not started yet.
Okay. Okay. Sorry. Oh, show. Okay. Excuse me. Okay.
It's coming now. Thank you very much.
I will start now. Okay, I will just go directly to the second. 对于我国大多数的中小型城市和通上自来水的乡村来说呢，湖库是我们主要的水源地，湖库的水质管理自然是关系民生的重要课题。作为水源地的湖库呢，最让人头疼的就是水华和有害藻类的问题。2007年的太湖蓝藻给我们上了重要的一课。然而，湖库的生态系统复杂，外部影响和内部生态都是导致水华爆发的重要因素。准确定位湖泊生态系统对湖库的水质管理起着至关重要的作用。今天呢，我就希望从模型的角度来阐述一下，我们如何能够更好的知湖治湖，少走弯路。湖泊呢，和我们的人体一样，有自我调节功能。湖泊的富营养化往往以水体能见度低、藻类爆发、水生植物少、鱼类结构失衡等为特征。这一般呢是营养盐过剩的问题。湖泊一旦进入富营养化，生态系统就进入恶性循环，形成新的平衡，很难再回到初始。这时就需要进行人工修复。而湖泊的营养化和生态修复过程并不像我们想象的那么简单。右图的著名稳态转换定律阐释了这个规律，也就是湖库的富营养化和修复过程都要面对湖泊本身的生态抵抗效应。湖库的状态什么时候发生质的变化，这和本身的生态系统呢息息相关。这次我要介绍的模型 WET 就是以这一套理论为基础开发的。湖泊的生态系统复杂，研究的尺度跨度也很大，根据不同目的开发的模型呢纷繁众多，但是大部分的模型一经开发，项目结题就束之高阁，很少再见使用。大家比较熟悉的澳大利亚的 Cadence， 美国的 C=W2， 英国的 Protect 和荷兰的 PC-Lake 是业内比较频繁使用的。而这些模型呢，除了 Cadence， 大部分不考虑水动力过程。然而对于湖泊这样一个静态水体来说，生态过程对水动力、水温和光照都有着直接的影响。比如湖泊表层的藻类会遮挡阳光，捕食底栖动物的鱼类会搅浑水体。Cadence 呢，原来并不是开源模型，近几年呢开始转为开源。2012年，我们在原有的 PC-Lake 的基础上，结合了实时耦合水动力，形成了 WET 的雏形 7 PC-Lake。7 PC-Lake 如左图所示，包括了水体和底泥的生地化反应、水体与底泥的交互系统、代表性的3种藻类、1种浮游动物、1种底栖动物、1种沉水植物和3种鱼类。自从16年第一版发布以后呢，我们持续进行了开发，形成了右图的 WET。我们融合了Cadence、EcoPath 等其他生态模型的优点，并且呢实现了模块化。现在可以根据湖泊的具体情况，任意定义各种组分的藻类、浮游动物和鱼类等。现在比较成熟的呢是1维模型，也是我本次将要介绍的。我们的3维模型呢更加适用于大型的湖库的模拟，目前呢已经完成开发，正在调试。在介绍具体案例之前呢，我想给大家简要的介绍一下湖泊的建模过程，以我们的纵向1维为例。首先呢，我们需要收集湖泊的边界条件和初始条件，比如水文气象数据、入湖、出湖河流、湖泊内部的水质和水生态数据。这些数据呢，一般需要长期的。边界条件作为模型的输入条件，湖泊的内部数据呢，要分成2组，一组用于预定，一组用于验证。预定和验证的过程呢，都是将模型的输出结果与监测数据相比较，唯一的不同就是预定过程呢需要调节模型内部参数，而验证过程呢模型不能再调整。如果验证不通过，那就需要进行重新预定。预定和验证的过程循环往复，往往非常耗时间，但是一旦 模型验证通过之后，我们就可以用模型进行情景模拟，这样我们就可以模拟，比如说营养盐复合变化、未来气候变化或者多种因素结合对湖泊产生的影响。下面就向大家介绍一下Irrigation在丹麦深水湖富勒湖的模型。富勒湖呢，在上世纪末和本世纪初经历了营养化和人工修复的过程，其中重要的一项措施就是在湖底泵养，以求改善底部的生态环境，减少底部的营养盐释放。图中的曲线就是从2003年到2006年每年夏季当地湖泊管理部门对湖底泵养的一些数值参数。我们的模型呢，在预定和验证期间表现都非常好，吻合度达到业内先进水平，特别是在验证之后模拟泵养过程中，模型能够在不改变任何参数的条件下准确抓取水中溶氧的变化。大家再看纵向一维图，横坐标显示的是时间，纵坐标显示的是水深，渐变色的红色端代表最大值，蓝色端代表最小值。大家可以明显看到，在泵养过程之前呢，该湖呢夏季底层的厌氧层可以达到水下20米左右，泵养后呢厌氧状态明显改善，紧接着底部的磷酸盐释放也明显降低，藻类也就是叶绿素水平与前几年的夏季相比也明显降低，这跟当时项目监测到的数据也是非常吻合的。这就是动态湖泊模型的优势，模型一旦验证通过，对于可能的内外部条件变化，模型都可以给出一个准确的评估。下一个例子呢，是青岛的吉红滩水库，是我们中科院武汉水生所丑庆川博士的工作。吉红滩水库是全国最大的平原人造大型水库，位于青岛市的西北部。随着当地城市的发展和流域的开发，该水库面临一定的富营养化危险。根据历史监测数据，我们建立了Irrigation模型，通过了滤镜和验证，最后通过模型的情景分析，对不同营养盐复合条件下藻类的水平进行模拟。我们的模型呢，对水温、溶氧、总氮、总磷等滤定和验证过程表现都非常好。由于时间原因就不具体介绍了，大家可以下载我们的论文查看。在情景模拟中呢，我们对外源的氮磷的不同复合条件下的叶绿素水平进行了模拟。左上图呢显示了氮复合在递增和递减的19种场景中的叶绿素的变化水平，左下呢是对于磷复合变化下条件的模拟，右图呢是对于氮磷同时递增和递减过程中叶绿素水平的模拟。模型显示呢，该水库主要对磷的复合非常敏感，所以相关流域开发和管理要十分重视磷的管理，比如施肥、洗涤剂的使用等。本人年初呢加入了 NIHAS， 着手开发湖泊数字孪生系统。对于孪生系统的设计分成3个阶段，第一阶段为数字建模阶段，第2阶段为运营调试阶段，第3阶段为智慧管理阶段。Wet 以及其耦合的水动力模型都是完全开源的模型，和其他商业模型比较起来呢，在进行数字化管理软件开发的过程中完全没有壁垒，智慧系统开发和运行都更加的有自由度。需要指出的是，智慧系统的其他技术都相对成熟，我国有诸多优秀的软件工程人才。然而湖泊生态和过去半个世纪的生态监测是很难在短时间赶上的，所以像 Wet 这样成熟的生态模型是对我们生态系统和监测系统缺失的一个很好的补充。最后，我来自西子3千的千岛湖，现在呢我加盟了北欧一家以创新为科研为特色的咨询公司 NIHAS。 知湖治湖是我的热爱，我淳朴的希望就是像我的家乡千岛湖这样抱湖而生的地区，有田地可以耕，有鱼虾可以吃，有清水可以喝，闲来无事呢还能荡舟湖心，岛上一游。谢谢大家。
Thank you very much, Fen. Your passion for this work was definitely felt. Thank you very much. We will, in this small group of digitalization, we will immediately pass the floor to Luca Bobo. But for download of PPTs, etc., I will put in the link. And of course, everybody is welcome to approach the speakers directly. Thank you very much, Fen.
You're
Luca,
welcome.
the floor is yours.
Yeah, thanks, thanks, Eric. Let me share my screen first. Okay, I guess right now you should see my screen. Well, first of all, I would like to introduce myself. I'm Mr. Luca Bovo, and I'm working with Sommermess Technique. We are an Austrian company. We have different offices all around the world, also in Asia. And today I want to actually show you one of our latest product. It's called SQR. It's one of our latest non-contact flow meter. And well, this product was specifically designed for sewage water, wastewater, and wastewater treatment plant. So how it works, this sensor is a flow meter. As you can see, the sensor is outside of the water. Here, a small drawing and example. The big advance and big plus of this type of product that we are kind of the promoter of this non-contact technology is the really low maintenance and calibration. So after the installation, you don't have any additional cost. But the other big plus that we have it and we propose is basically turbidity or whatever you have in the water. You can see here, again, I will play this video. There is like some foam, but could be even more. This is not affecting the measurement, okay? And the sensor is equipped with two radar. You can see a velocity sensor, which is measuring the velocity, the flux velocity and the water level. But the big plus of it is the advanced and dynamic hydraulic model that we developed like almost 20 years ago. We start some application in rivers. So you can imagine the hydraulic model is quite advanced, is on board on the cross section. And thanks for this hydraulic model, we can calculate the correct mean velocity and the flux. Of course, you need to configure the cross section, the profile, the material. But something really easy. Our software is a really, step-by-step software, and basically you don't need any specific and technical skills to configure it. And thanks for this hydraulic model and the latest radar technology, we provide high water data reliability and quality. Here's some picture. I like it. I think it's also here you can really see like the sensor is outside. Okay, so it's protected. It's really fast and easy to install it for you guys. And basically whatever you can have here, the sensor can still work and can assure you data. There is no minimum flow required. There is no specific indication regarding the cross section. You can configure it. You could be trapezoid, rectangular, irregular. So basically with a point-by-point configuration, you can set up irregular cross section. But also the sensor is really smart and has a data quality indicators for validate the data and an automatic self-check. Also quite important, I want to underline, even generally, especially in wastewater treatment plant or in sewage system, you can have main electricity. The sensor has a really low power consumption. So you can think to power it with a small battery, or even if you have a solar panel, you can power it by it. Here actually, I just bring one video. We have one in our YouTube channel. And it's quite interesting. This is a video actually from Central America, where they are suffering, heavy rain. Also, you can, even in China or Asia, everywhere, we are facing heavy rain due to the climate change. And this is, of course, affecting, our sewage system and the wastewater treatment plant at the end. So with this sensor, you basically can have like online data and basically take better decision, fast decision, and manage better your sewage system and your water treatment plant. So here you can see the sensor working in different cross section. This one is an example, with the data logger. You can see they installed in this case, the battery and the solar panel on top of a mast, so quite secure. And the sensor could be combined with data loggers who can only store data, also can transmit data. via satellite, via radio, via 2G, 3G, 4G. And actually there is no need, I want to specify, no need of structural work. So basically you just go there and just in a few minutes, you can see, thanks also with the design of the product, this is stainless steel, high quality. You can basically install a really small mast of support, and the sensor, that's it. Basically, the sensor can start work. You know, in less we count in less than 30 minutes, you can go there, configure the sensor, and install it. But actually, if you configure the sensor, you know, at home or at your office with your PC, because the configuration is made by your PC, basically you can save a lot of time, and basically just in a few minutes you can install the sensor. The sensor is made with a specific plastic material, which allow us to install the sensor in quite aggressive chemical situation. You know, this is a picture from Hong Kong. But even, you know, it's not required any cleaning. The sensor can go under the water because it's IP68. But you can see, thanks to our design, even the sensor is going under the water. Yeah, we are going to have air pockets. So again, is not need any cleaning. You can see here is pretty dirty, but the sensor is still working, and you don't need to go there and clean it and do any maintenance. The sensor also has a standard output, which means you can basically integrate in your SCADA or in your system, in your plants with no problem. We are using like an analog and digital output. So basically you can do a lot of things. And also with here, this is the example of one of our model for the data logging. Some of our customers like to have like a quantity measurement with quality. So you can think to have in the same station, for example, water quality measurement together with the SQR flow meter. Well, the application until right now, we just talk about sewage water, but the application could be like really a lot. Here, actually, this is like the inlet of a hydroelectric plant. Okay, so you can see here is quite big, while here is a normal sewage system, and you can see the big difference. Even like here is quite turbulent, while here is a little bit more calm, the water. One of our, in my opinion, really cool application and future that you can have with our sensor, if you want to do like you want to monitor your sewage network, basically with this sensor, with this non-contact technology, your technicians, your guy, they don't need to go inside of the sewage system. You know, could be quite dangerous. You need to wear masks, special and specific protection. But yeah, basically you go there, and as we saw before, you can stay outside, okay, and basically land it down the sensor, and that's it. Everything again could be powered by a small battery. Here an example of 22 ampere hours battery, and you can see you can have like a 10 weeks of a power autonomy with, you know, data recording and also data transfer. Actually, the data transfer per day is the most power consumption part. And you can see here the sensor is down here, and you can combine it with a simple data logging or data logging plus data transmission. Here a good example from Korea. What is really interesting, you can see here we're just talking about of some liter per second, okay, and a really small pipe. And for example, here in US, you can see here quite a really high turbulent and high speed water, okay, and we're talking about in this case some cubic meter per second, okay, compared to this another storm water pipe, okay, where it's really calm. So how this is possible? This is possible due to our hydraulic model, which, as I said, is dynamic, okay, based on the condition. The sensor is really smart, can recognize what type of situation you have at each water level and velocity it's measuring. Another good example of storm waters from, okay, South America and Japan. This actually was a really interesting network. This was a network, for rainwater. Japan is eaten by a lot of hurricanes. So basically you can have this type of canals where you have a really calm water, but in a few minutes, you can see like your water level rising a lot. Okay, so really flexible hydraulic condition, and then a really high velocity water. Okay, so basically you can think to install the sensor not only in pipes but also in open channel. Again, you could have like an industrial application, could be, for example, a hydroelectric plant. So also we can measure like whatever fluid you have in your process. Could be irrigation channels, since we don't have any limitation in channel size and flow in terms of minimum or maximum. And
1 minute, Luca.
Yeah.
1 minute.
Yeah, I'm almost done. Don't worry, Henrik. And I want to repeat again, the cross section could be irregular. Just my last slide here. This is an example of irrigation channels where actually they want to have like an automation, with gate and everything to control better the water distribution. You can see the sensor is outside. Okay, again, they power with battery and solar panel. And it's safe here. No animal can damage. There was like a problem of alligator over there and other animals, really eating cables and eating sensor. So it's basically up here, whatever condition you have here, the sensor can measure it and is safe from animal and even vandalism. Thank you for your attention. I hope it was interesting and clear. And thank you, Eric, again for this opportunity.
Thank you very much, Luca, for another interesting presentation. I was particularly enjoying the fact that you are protected against alligators eating the cables. Which type of problems don't we have to face? Anyhow, we will be moving on, and it will now be the presentation of Mr. Herbert Chan from UROS. Another presentation which is within our digital section. Herbert, please.
Hi, let me share my screen. OK， 各位下午好，那我是来自UROS 的 Herbert 陈文超。那我今天主要讲的是在智慧城市的这个效率方面，如何能够提升在运营中还有在整个功能整合上面的这个效率。首先的话，我想先介绍一下我们自己。那首先我是香港中友科技，也是这个芬兰 UROS 公司在大中华区的这个负责人。那目前的话我们是在以诺基亚这个智慧城市整个生态系统上面的一个系统集成的一个成员。目前来说我们现在在国内的话，跟一些大的国企，还有一些这个研究机构呢，都有比较多的合作。那像在北京的话，跟这个北京市的这个京城机电集团清华大学还有北京工业大学等等，中国建材集团都有我们的合作。那么同时呢，在芬兰方面除了诺基亚之外，那UROS 本身是一家提供这个水质监控，还有这个 流体力学模型的hydraulic model 的这样的一个解决方案的公司。那同时呢，我们也跟这个芬兰的这个水协Finnish Water Forum 以及其协会属下的所有的成员呢有共同的合作。那我们的目标呢，就是通过整合芬兰这些大小企业的这个水资源方面的这个解决方案，然后把它介绍到我们国内来挑选我国目前适合我们国情所需要的这样的一个解决方案。那在过去的几年的工作中呢，我总结了一些我认为在智慧城市，特别是智慧水务的项目上面推动的时候，我们面对的一些实际的困难。那在这边主要跟大家分享一下。那首先的话，其实在项目的推进过程中，那由于各个地方这个情况的不同，有很多的这个管辖范围数据权限都存在着跨部门的这种多重管理的情况。那么其次的话，因为我国这个幅员辽阔跟这个北欧或者是说其他的欧洲国家不一样，那每个国家每个地方每个省市的这个情况呢都不尽相同，实际上是很难把一个单一的一个解决方案呢进行简单的复制比如说我们在这个在兰州在四川甚至是到了我国的这个香港地区，那我们面对的困难呢基本上都是完全不一样的。那么一个单一的一个解决方案其实是没有可能从头到尾就这样的简单的复制上去。那这中间呢就需要我们根据各个项目的实际情况呢进行非常根据项目呢进行调整。那么在很多的城市里面就算是一线的北上广深这样的大城市，我们也发现就是说总是有一些老旧的城区它的管道的情况呢是非常的不明确的。包括了说这个有没有当时的图纸那甚至是有一些这个已经埋在地下已经超过了50-60年以上的这管道，那么如何能够去获取这些管道的信息，能够建成一个3D 的模型这也是我们在跟各个城市之间进行互动的探讨的一个方向。那么到了一些并非1、2线的城市呢或者是到了这个城市以外的乡镇地区，那我们会发现说对于一些现有的或者是旧有的管道呢大家都缺乏一定的保护，那造成了管道本身的一个破损。那其实没有管道的话，那其实都讲不上这个水务上面的一个管理了。那在整个行业的智慧水务或者甚至是智慧城市的这个推进方面呢目前各地还是缺乏一个统一的一个标准跟一个推进的一个规则，造成了在推进的过程中呢到底如何去判断或去这个检讨最终这个方案的结果或者是说对于这个质量的一个检验，那如何达到各地政府满意的一个这样的标准，还是需要有很多的工作去做的。那么现在自从2020年以来，我国推出了这个新的数据安全法。那么对于一些跟外企在合作的过程中呢，由于一些数据处理上面的要求，那如何能够安全有效的既能够实现这个数据安全处理的这个要求，那同时也能够确保这个外企能够实际上的通过运用这些数据来为我们进行服务，那这也是我们目前正在不停的尝试跟探讨的一个过程中。那么这也就是刚才我们提到，就是说为什么我们跟一些国企或是说一些这个国内的比较著名的学校来进行合作的原因。那只有把这个最终的数据，或是说这个整个软件的这个运算的这个主动权掌握在我们自己的手里面，那这样才能够真正有效安全的为国家在智慧水务这边进行服务。那么在这个推动的过程中呢，我们逐步引进了跟诺基亚这边进行合作， 引进了他们的整个这个叫做开放性的可协作的一个架构，Open Interoperable Architecture。那么其实呢，我们可以看到，就是说在整个水源的处理上面，整个环节上面来说，我们从地表水源到水的运送跟这个发送到各个管网内部然后在居民的用水跟最后的一个污水的一个处理，那这样就形成了一个比较完整的一个循环。那诺基亚的概念就是说，这个平台的概念就是说，充分运用诺基亚在数据跟这个数据平台管理的这部分的一个经验，那么可以通过他们在各地建的这个NB-IoT 的这样的一个网端，能够集中有效的把所有的整个这个智慧城市特别是智慧水务这一块的这个所有的数据能够整合到一个统一的平台上来，用一个同样的一个标准来为这个城市的管理这边呢进行服务。那当然中间也包括了很多这种遥距的这个维修维护资产的一个管理如何这个设定这个工作的流程特别是在对运营的过程中参与的这些各个商业的团体，如何设定一定的这个商业规则然后同时提供数据这样的分析这个是诺基亚这个平台目前想要达成的一个目标。那在这个整个架构里面，我想着重的说几个方面吧。第一个就是在digital water metering， 就是叫做数字化的这个水质的一个水务的一个测量方面，其实从硬件上来说我认为我们国内的整体的硬件是非常的完善的，那也不缺什么特别除了一些比较特别的一个传感器之外，我们国内基本上都能够提供。那但更重要的是，就是说在跟外企合作的过程中，我们更重要学习的可能是针对一些不同的环境之下他们对于这个运算结果或者说如何进行运算能达到我们想要的结果这种运算的这个方法或者是说他们这个算法的这个一个推导的一个原则这个是我认为在整个合作过程中对于各大城市最有价值的一个部分。那么其次的话，我想说的是，智慧城市或者说智慧水务之所以我们认为说它是智慧，除了它能够在人工智能的基础上进行学习之外，我们更希望达到的就是它能够提出一些前瞻性的预警性的这样的一个建议给这些运营这个水的运营的这个管理方。那比如说在我们的解决方案里面能够对于整个城市的这管网做一个数字的一个沙盘也就是差不多跟现在说数字孪生的道理是一样的，就是做一个数字沙盘去模拟在任何这个水的管网里面发生故障甚至是这个发生一些这个天灾这样的情况下这些变化对于整个管网的影响会大概是怎么样的？那么这个就能够有效的为这个管网的一个管理人员对于将来的发生的一些变化能够采取有效的这个预防的措施。那同时呢，我们把这个水整个资源包括从一开始的天然水资源，甚至是管网里面的水资源都当成是一个资产来进行管理。那么如何让这个资产在整个循环过程中达到有效的利益最大化呢？这个就是我们在诺基亚的整个开放平台里面希望达成的一个结果。那么我最后想在这个地方说的一个就是说，我们在跟这个海外的这些公司在合作的过程中，我认为除了这些硬件或者是算法之外，我们可能更多的是应该要去学习他们在整个水资源管理上面的一个思想。那我们在国内的各部分，就是各大城市的这些进行水运营的这些相关的部门或是公司的话，也应该把这个以前从纯粹的硬件管理或者硬件投入的这个思维呢，更多的往这个服务的这个思维去转换。那这样的话呢，才能够更有效的来提升我们智慧水务的一个效率。那么最后呢， 我想最后简单的介绍一下我自己，就是我叫陈文超啊，我是正友国际的这个创始人之一。那目前呢，我是香港芬兰商会的董事会成员。那同时我也是 UROS 在大中华地区和亚太区的这个主要负责人。那如果大家对于我刚刚说的这些项目，或者是说有其他的问题的话，也欢迎随时联系我。Thank you, Henry. This is all my presentation. Thank you very much.
Thank you very much, Herbert. And hereby we will close the section of digital solutions. It's been very interesting to follow. I'll immediately pass on the floor to Bruno Di Puccio. We are running a bit short of time, mainly due to that I took too much with my introduction, but I hope our future speakers will be continuing the sequence of precise presentations. Thank you very much, Herbert. Bruno, the floor is yours.
Many thanks to the China-Europe Water Platform for having me today. So, yeah, my name is Bruno. I'm the Managing Director of Sewage China. I will spend the next few minutes to share some of our experience implementing smart operation and maintenance solutions for small and medium-sized water companies in China. So the key point that I will try to make in this short presentation using two case studies in small, medium Chinese cities is that small water companies are very often the best places to develop successful smart projects, successful in the sense of the benefits to operations, but also in terms of having a good showcase. Many of you in the Chinese water industry know our company, Sewage China. We provide O&M consulting services and digital solutions for operation and maintenance. More than 80% of our business is with environmental infrastructures. We work with all the large water companies in China. You see them on the right, such as Beacon Water, Capital Environment, the many Suez and Veolia joint ventures, and many more, as well as with municipal water companies. We've been in China for 18 years already. It's been quite a long time. The first case study I want to share is that of Nanchang Shuanggang water supply. It's a 100,000 cubic meter per day water supply joint venture between Suez, the French company, and Jiangxi Hongchen Environment, so the local water company. This company, Nanchang Shuanggang, was considered too small and too old to invest in smart solutions by the group company. So the project did not receive any support from the group. However, the local general manager insisted to run a project, and this is how they got started with us a few years back. So together with the local team, we actually used the ISO 55000 asset management standard to implement a digital solution focused on their top priorities. So the standard was a way for us to identify the priorities in terms of operation and maintenance, and then to deploy them through a digital project. I won't go into details here. The most important is to understand is we initially involved in consulting services. We helped them build the asset management and inspection processes, the business process. We implemented them in a digital solution. And we provided long-term services, which we are still providing today, 4 or 5 years later, which consists in yearly on-site audits, and we do monthly coaching for them remotely from our Shanghai office. This project has become a great success story, and that's the point I want to make within Suez Group, which was very unexpected for them at the group level. And it's actually used as a case study for Suez smart solution business, not only in China, but also abroad. And later, the Chinese side of the business, Hongchen Water, Hongchen Environment, also selected us to deploy the same solution, our smart O&M solution for their group. So there's a double expansion both on the Suez side and Hongchen Water, what I think proves the success of this small project, which again, nobody initially thought it was possible to do a smart project with such a small company. So a good success story. My second case today is that of Yuyao Water in Zhejiang province. It's another public-private partnerships between, this time between two Chinese entities, Capital Water and the municipal water company of Yuyao. I would say the approach was quite similar to the previous case study. And here, for those who are interested, there is actually a longer, a much more detailed movie case study, which you can see by scanning here, and you will get a copy of the slides. So I won't go too much into details here. I would just say that, again, instead of just installing software, digital solutions, what we did with them is to provide our O&M expertise, work with their operation team to help improve their operations. And as a result, these projects became a showcase, a real showcase within Capital Environment, the group, which is a big group with many projects all over China. It was visited by many companies. It's really a brilliant showcase. And I would say this project stands out compared to many other digital solutions we see in this group and in many water companies in China. And as you know, many digital water or smart water projects tend to be very IT driven, often result in very beautiful screens. You know, every water company in China has a big screen with KPIs and some 3D images, but quite often those systems are not useful in the day-to-day operation, and they are not useful to improve operations. So this project really stood out and has become a very good showcase. And that's another example of it, I think, what can be achieved with relatively small water companies. These projects, just a few words about these, they're all based on our smart O&M solutions, which have been used in many other environmental companies throughout China and elsewhere in the world. I won't say too much about this. One thing I want to say is in the water industry, and you have seen it in other presentations and many of your companies, there's many different software solutions used and many different software suppliers. Quite often the water company have themselves, they have an IT subsidiary. So we need to be able to cooperate with other system suppliers. And that's very much what we do with our solutions, which are designed to integrate within a smart water platform with other solutions, with a digital twin, with IoT software, with an ERP, with a GIS, with a BIM model. And of course, we are not only we can do it, but we're happy and we have to cooperate with existing IT suppliers. So I conclude with what I call here lessons learned from these two case studies, but more generally from our long experience in the market. As I expressed in the case studies, having a more industrial approach rather than software development achieves much better results. And this is why my company has been hired as a consultant for with many large Chinese water companies that have their own IT subsidiary, or they have a big IT suppliers working with them, and we are able to work together to deliver results. So our smart O&M solution can complement maybe a much more general digital twin or smart water solutions that seems to do everything, but actually mostly is just beautiful screens and getting data from sensors. So we have learned to cooperate in that environment. And then I would say, finally, our experience working with small and medium-sized water companies, and I gave you two examples, we have many others, we see that these companies present many advantages. They have much less constraints from the group, from corporate, simply because usually they don't have a corporate headquarters. They are not part of a big group, or in the examples I mentioned, they are joint ventures, so they are not dependent on the group. They can make their own decisions. They are less political as well, with less management levels. It's easier for them to make decisions. As a result, they have a more practical approach. They are more results driven, and we like that. And so this is an advantage. And at the same time, I would say people working for smaller water companies, they are not less skilled than those in big companies. At site level, I think they are quite similar to people working in big companies at the plant level. Of course, they don't get support from a large group, and there are pros and cons to that. I tend to look at the advantage of these. They can be much more flexible. So again, I think it's great to be able to work with smaller water companies, and we have developed, and I give you two examples, we have developed very good showcases, which for us as a company has helped us to develop the business further. And I think for these companies have helped them really improve their operations. That's all from me today. I tried to be brief. I apologize if I speak a little bit too fast. Thank you very much. I put here some contact details. You have mine. Don't hesitate to reach out to me. And with a mobile phone number, you can find me on WeChat as well. And some of my Chinese team members, this is basically our smart water team. Feel free to contact any of us if you have any question or project opportunities, and I'll be happy to answer questions during the panel discussion a little bit later. Thank you very much.
Thank you very much, Bruno. Brief, yes, but once again, as always, very interesting from your side. I will suggest you and the other speakers to provide your contact info directly in the chat if anybody wants to follow up immediately. And with this, I will leave the floor to Jingjing Ma from Nordic Group China. Jingjing, please.
Okay. Here's my screen.
Yes, thank you.
Okay, thank you very much. I would like to share our Nordic design experience in China on the rural water and ecological design experience. 那么非常感谢 Herbert， 那么我还是用中文来说。我想分享一下我们诺丽奇在中国的20年这个在乡村的这个生态环境提升以及综合解决方案方面的设计经验。那么今天我的演讲分成3个部分，一个是简单介绍一下我们公司的背景，第二个是我们在这个中国的这个“14-5”规划中相关的水管理方面的目标。第3个是我想重点分享一下我们目前在乡村振兴方面，我们正在执行的一个生态环境污水的一个综合提升的国际项目。那么希望就是有问题或者有感兴趣的可以下面来联系我。那么我们是谁？诺丽奇，我们是2015年在丹麦成立的工程咨询公司。那么我们在国内有将近30年的一个这样的项目工作经验。那么我们的主要的业务也是在这个零碳可持续的规划设计咨询方面。那么在这个乡村的振兴方面，我们在过去10年也一直在探索一些适用于中国国情的这样的一个污水城镇的开发的一个这样综合一体化的方案。我们是来自于丹麦哥本哈根，那么我们现在在全球有4个办公室，然后我是在这个中国北京负责中国区的业务。那么我们的使命是致力于这个提高我们的城乡的这个生活品质。那么同时我们和我们这个北欧的这个团队进行紧密的一个合作，来挑战我们的思路和我们的一个设计的一个方式。那我们在国内的和北欧的主要客户也是以政府为主。那么我们在国内的话，我们的这个主要的核心的区域也是以这个北京京津冀地区，然后上海长三角以及我们的福州的这个福州的都市圈和这个成都的这个都市圈。那么中国的这个3060的双碳目标，可能大家也比较清楚了。那么我就快速的过一下，就是说国家在这个去年这个2020年提出来的我们一个双碳目标。那么我们在2030年之前，我们要实现我们的这个碳达峰。那么我们在2060年要实现我们的一个碳的一个中和。那么在这个“14-5”的最新规划里面，关于这个水相关的一些绿色指标，我也给大家做了一些做了一个这个总结。那么水务行业在这个“14-5”期间的主要的这个关注领域会在这个乡村振兴、绿色产业发展以及我们的这个农村的这个生态环境的整体的这个生态文明建设方面。那么我们相对于这个2018年的中国的这个绿色产业的一个投资，那么主要的这个投资主体会转到我们的农村的这样的一个市场。相对于2019年的一个这样整个中国的这个水环保产业的一个投资额是在17.8万亿的一个这样的盘子。那么在2045年在达到2025年的时候，我们将会有一个 11.3%的一个提升。在这个十四五的这个去年发布的这个正式的14.5的规划里面，有2条非常重要的跟这个水气候相关的这个条例。一条就是11.38.5，就是说明确的规定了我们在这个国家全面的这个污染排放的一个这样的管理的一个体系。那么我们在我们的这个用水方面明确了这个水船的一个使用，以及我们这个碳排放的一个使用的一个权利。那么我们在那个11.39.1方面，我们也明确的规定了这个提出了国家的一个全国性质的一个水保护的一些项目和我们的一个目标。那么在这个整个在14.5期间，对于这个节水的要求是比较高的，不管是在这个大城市也好，在这个小城镇也好，那么国家是大力鼓励这个使用这个节水型城市，这个城市再生水。在这个到2025年，这个我们要实现一个16%的一个这个水消费的一个减少量。那么我们分享一下我们现在在这个乡村做的一个正在进行的一个项目，也是一个国际的一个 NBS 的基于自然的解决方案的一个项目。那么这个项目是在位于这个福建平南。这个平南是距离这个福州差不多是120公里西北角的这么一个小的一个县城。它是大家从这张图上可以看到，它是一个非常这个依山而建的一个这样的非常有中国代表性的一个这样的小县城。这个范围这个人口的话，差不多常住人口是在14万人口的这么样的一个规模。那么这个长芬溪是这个是整个这个穿过这个县域的这个城市的这个县城的这个中间。那么它这个河道的话是非常狭长，而且大家也能看见，就是说这个城市和这个河道它是一个共生的一个概念。这个在这个之前在建县的时候，这个上游的这个山泉水冲流下来，那么经过这个城市河道，然后给城市带走这个污水。那么在这个伴随着这个城市的发展以及这个县域人口的增加，那么这个河道它已经不再能承载一个这样的一个生态的径流的一个这样的要求。那么同时，由于这个气候变化，在上游的话，对于这个20年一遇的这个洪水的这个影响，对于这个城市的防洪来说，也是一个非常大的一个挑战。另外就是说，这个由于它的这个由于这个我们这个长芬溪它这个穿城而过，它又是一个非常狭窄的这个平均的这个宽度只有20米的一个这样的河道。那么长芬溪现在目前的这个环境和这个洪水的这个挑战是非常大的。整个我们这个项目是要修复长芬溪这个穿过城市的3.1公里的一个这样的河道的范围。那么我们在这个项目里面要打造一个国际示范的一个恢复长芬溪的这种生态景观的功能。那么清理长芬溪这个河道里面的污泥，以及我们在这个项目的这个设计过程中要形成一个这个 NBS 基于自然解决方案的，在长芬溪中能够恢复这个水环境、水健康，能够提升这个目前这个劣五类的一个水质的一个现状，能够恢复我们长芬溪的一个这样的这种蜿蜒曲直，能够成为一个这种生物多样性和栖息地的一个这样的基础。那么这个项目里面的话，我们的这个目标也是要打造一个这种生态的这种蜿蜒曲折自然的一个河道。在我们这个项目的过程中，我们分成了这个8个阶段。那么我们先对这个河道的这个流量进行了诊断，那么我们对这个标准断面进行了设计，然后同时长芬溪它历史上它一共有18座堰。那么我们在这个项目的这个洪水分析和这个水动力模拟的前期，我们也对这个堰的这个过水的这个动力进行了这个模拟。那么我们将拆除这个3座这个水坝，然后来进行对剩下的15座坝进行一个生态的一个这种恢复。同时对我们整个长芬溪的一个河道进行一个这个改造，进行一个生态化的一个改造和这个最后形成一个这样的能够既可以适应我们这个20年一遇到100年一遇的一个这样大洪水的这种冲击，同时在这个长芬溪平时的这个跟城市的这个关系也能形成一个非常好的一个城市的一个这个城市这个绿网中的一个核心的一个绿道和公共空间的一 个场所啊。那么我们在这个项目里面也是用了我们的一个这个灰绿蓝的一个这样的规划方法学。那么我们以这个长分析的这个目前的现状的硬质河道作为我们这样的一个蓝绿廊道的一个基准一个这个水位线。那么我们将这个长分析的这个水质污水进行截污，水质进行提升，生态进行恢复之后，然后提升这个长分析两侧的一个这样的这种公共空间和口袋公园的一个这样的高品质的环境。整个项目过程中，我们是用的一个这样的一个基于自然的解决方案的一个生态的一个手段。那么在这个上游的这个截污过程中，我们也用了一个我们也采取了一个这个从这个源头截污到这个污水场站的这个设置，到这个整个长分析内源污染和外源污染的一个综合治理，到最后我们这个项目能恢复成一个长分析自然的一个生态曲折的一个这样的水的一个动力和一个这样的自然环境。这个是左侧是我们的这个长分析的这个现状，我们也是分成了6个不同的这个断面。那么基于我们这个长分析从上游的这种自然河床段，到我们的经过城市里面的这种水动里的这种适合于生物廊道的这种栖息的一个这种垂直段，然后到我们后面的这个自然工法段，然后到我们的这个长分析的这个水质提升，打造成一个这样的人工自然生境段。然后到最后我们的两江汇合的一个河口缓冲段，和最后的一个我们这样的低影响开发的一个这样的这种自然恢复的一个片区。那么我们这个项目也是能在这个3.1平方公里范围内，我们3.1公里的这个长度，我们能打造一个这样的非常有活力的一个中国式的一个 NBS 的一个综合解决方案。那么这个是一个英文的一个翻译，大家可以看一下。最后在这个两侧的这个水生境、水环境、水动力方面，我们也实现了一个这样的综合的6位一体的水环境的一个示范。另外一个项目是我们乡村振兴相关的项目，是我们在这个湖南经市的这个毛里湖国家湿地公园。那么这个项目的话，我们也是一个紧密的以这种生物多样性为主来开发的一个乡村振兴的也是一个这种生物多样性的一个示范项目。那么我们在这个项目里面也是作为主要的一个工程的设计咨询方，提出一个基于这种生物多样性保护的一个示范的一个技术。好，因为时间有限，那我们也是在这个联合国的 SDG 的不同领域中提供我们的相关的这个设计和咨询啊。那么我们是在中国主要是目前是在这个北京。OK, Herrick.
Thank you very much, Jingjing. Another comprehensive presentation from your side, and congratulations with the 3-year anniversary of your China division. We will quickly move on to Mr. Peter Gregerson.
Yes, thank you. Can you see my screen now?
Yes, it works.
Okay. I'm not smoking, and I haven't been drinking, but my voice is really bad, so it's simply a sore throat I have. I hope you will understand me anyway. A short introduction of myself. My name is Peter, and I have been working with zero discharge recycling systems since 1996, where I developed it here in Denmark. We have made systems between 15 square meter and up to 350,000 square meter. I think, well, actually more than a decade ago, 15 years ago, we made a joint venture with a Chinese person, and from that we made a new company who has worked with planted filter systems for now more than 15 years. What is a zero discharge system? It is a system without any outlet. In that way, it cannot affect the water environment at all. And what are we using them for? We're using them for household wastewater, process water, stormwater, or any other water with nutrients, and also, for instance, household water with the sludge. We also use this, and we have a new approach. We say if we are able to take up the nutrients and organize the organic matters into soil, then we will have nothing which pollute anywhere. Because if we take it up, we'll have it in the stems, in trees, or some other plants. But we will use this source for producing biomass. The biomass can be recycled, can be used for soil conditioner and nutrients for farmland. It will bind the carbon for several years. Biomass could also be used for biomass for heating, and then you could use the acids as a nutrient. This is not a good idea unless it substitutes coal or maybe gas for heating. If it is, then it is also binding a lot of carbon dioxide. We are using it into a double circle system. I'll show you what it is, but first I'll just remind you what this zero discharge is about. Well, it's possible for us, because we have developed the principle, to calculate how much wastewater we can put in a system with trees, because these trees have evapotranspiration through the leaves. The water goes to the air. Then you have also some precipitation, and you have to keep a balance between wastewater and precipitation and the evapotranspiration. This is not the same all year round, but during the winter, we have moved so much water from the soil that there'll be room as storage during the winter. And remember, this is trees. It's trees that are growing, and they are producing. And they are producing because they uptake nutrients through the stems and leaves. Some of the leaves fall down again. Some nutrients comes from, especially nitrogen, comes from the atmosphere. And we have some wastewater coming in to this system. Now, and we are uptaking these. We are using them. If you use them, they don't make mess anywhere else. Sorry. Now for the double circle system. We start, hope you can see my cursor. There's a small house here, and we start with taking all the wastewater out, including sludge. And here in this picture, we distribute the sludge and the wastewater into a system. This has been dug out and has been put a liner. And then we plant some trees. In this case, it's in the southern hemisphere, so it's eucalyptus trees. And then in the middle, in this case, we make some sludge, which is naturally dried, less than 30%, so you can even transport it. And we also produce some wood chips. And this could be in a small circle, so we could use these wood chips for heating in the household, and therefore we have a small system. But this is full of nutrients. This is full of carbon. This is full of a lot of minerals. This wood chips shown in the upper area here, and it could actually be used to put into farmland. The carbon will be stored for many years, and it will make the nutrients available for as a fertilizer, as a ground fertilizer for many years. That's what we are calling a soil conditioner. When you have a lot of carbon, the soil can also contain a lot of water. So when it's raining, it's not running off; it's staying in the ground with this very good soil. The humidity goes into the air, and this goes into the crop nearby, just nearby, up to 150 meters away. It will make the air more humid, and therefore the crop can grow, and and the crop is also used for consumption. And we can do that because this step, the wood chips that we made from the first circle, this is without any sanitation risk at all. So we can harvest it, we can make bread of it, and we can put it into the food, and then we have the next circle. So it's a double circle, and in this way it's safe, hygienic, safe to do it all. Sorry. Here again, in this eucalyptus system where which we use in a desert. Well, it's actually a desert-like subtropical area here where we have used it, and it's producing 71 tons of dry matter per hectare. That's really, really, really huge, and therefore it's also binding a really, really big amount of carbon dioxide. And beside that, it takes up 50 kilo per hectare of phosphorus, 380 kilos of potassium. And actually, this is done in an organic way, taking from your own food. So, well, potassium has a cost of about 10 Danish crowns, the same nearly the same in yuan per kilo. So that's actually a huge amount of money.
1 minute, Peter.
Yes. So the sludge comes out also. This contains a carbon amount of 70,400 kilo per hectare per year. Phosphorus also very much, and potassium the same. So actually, this is a really, really good system with special benefits. It can be used for fighting desertification because it brings organic matter to the soil. Evaporated water from facilities will make surroundings more humid. Evapotranspiration makes the area around colder. So during the hot summer, it will simply put down the transpiration of water from this area. The biomass from the trees is used for soil conditioner and fertilizer for a new area. So the biomass from sludge is also used for soil conditioner and fertilization. And assimilation in the trees converts carbon dioxide from atmosphere to oxygen and to biomass. All areas with trees makes biodiversity, reduce the wind speed. So it's a start of a new forest agriculture. And in addition, your water environment will be totally clean and for free. And we are also able to make this system in a way that you can take water out. All it takes is sunlight, wastewater, some area, often wasted land, and a small pump to distribute the wastewater, including the sludge. And that means it will meet all these demands, which is for the future of using very little energy. Thank you very much. I'll write the name of the Chinese joint venture company in the chat.
Thank you very much, Peter. And now to the final company presentation, Dian van Oorschot.
Sorry. Okay, nice. Yeah.
Okay. It seems I can't start my video because the host stopped it. It says, well, I will start sharing my screen. Okay, this is the first one. Let me introduce myself. I'm Dion van Oorschot. I'm the director of Rietland, a company in Belgium. And Rietland has been designing and building constructed wetlands or treatment wetlands since 1996. In the beginning, mainly in Belgium and in the Netherlands. But we have moved also to international projects, for instance, in the Middle East. And we have a collaboration with a Chinese partner in Suzhou, the Tehua. And we are now working also in Kenya, where we are starting a project with wastewater treatment and reuse, which will come back later in my presentation. Okay, I will first start with some explanation about constructed wetlands. Constructed wetlands are basically natural treatment systems that mimic processes that also occur in nature. If you discharge wastewater into a small river which has plants in it, then the wastewater will be cleaner at the end of the river, because the microorganisms living on the plant stems and in the soil below the river will play a role in cleaning the wastewater. But of course, the amount of wastewater has increased a lot during the last hundreds of years. So the capacity for natural systems to treat the wastewater has been exhausted. So we need to clean the wastewater now before discharging it into rivers. And what we do with constructed wetlands is that we mimic the processes that occur in nature, but we intensify them on a smaller surface area. That's basically what we do. So we have here, you see the three classical types of constructed wetlands. On the left, you see the free water surface wetland, where the wastewater streams between the plant stems. The plants are, most times they are reeds. And then the next step was when German researchers discovered that the treatment goes more efficient if you let the wastewater stream underground, so between the plant roots. And that led to a third type in the end, where the surface area was even smaller, and that was the vertical flow wetland, where the wastewater is distributed on top of the system, and then it percolates down through the substrate, and it leaves at the bottom of the wetland. So in these subsoil systems, the microorganisms grow mainly on the substrate material that can be sand or gravel or expanded clay aggregates. So this last system, the vertical flow system, was the most efficient classical type of wetland, and it requires 3 square meters per person. But it's still quite a large surface, of course. So what we have been doing together with our partner in the United States, Naturally Wallace Consulting, they developed a system where these natural treatment systems, the wetlands, are enhanced with aeration. So now we have 3 different types of aerated systems. The classical aerated wetland that you see on the left, we call it phyto-air. We developed a new system that we also patented, where there is no reeds any longer, but grass tiles that you can also use as a parking. That's called a phytoparking. And then we have the really small system for single households. It's a prefab system in a concrete basin called the Phyto Cube. So that's the Phyto series that we developed for the European market in the beginning. Okay, to start with the first system here, you see a cross section through the system. It's a basin basically. It's a liner basin where you see the wastewater coming in the orange pipe, and then on the bottom you see the gray pipes. That's the aeration pipes, and then at the end the wastewater, the clean wastewater leaves the system through the blue pipe. So this enhances the functioning of the wetland a lot, because the bacteria that clean the wastewater, they also need oxygen, and we bring the oxygen artificially into the wetland by means of an air blower. So in that way, you can reduce the surface further to 0.75 square meters per person. So that's a factor 4 smaller compared to the vertical flow wetland. And also, if you start aerating a wetland, the classical wetlands, well, they are as they are. You build them, and well, you cannot do anything in terms of influencing the processes in the wetland. But if you start aerating it, you can also switch the aeration on and off, and that warrants a much better total nitrogen removal. Well, as you see on top on the photograph, that's an aerated wetland where you see the bubbles of air coming up between the expanded clay aggregates. So that's what it looks like in real. So this is an example of a system that we built in the Netherlands at a strawberry farm where they grow strawberries. And in the background you see caravans where the harvest laborers live. It's 50 persons living there, so this is a relatively small system. But here we clean all the wastewater from the people working there. And on the right hand side you see the results that we obtained there, and they are quite good. We remove almost all the organic matter. You see BOD and COD 196% respectively, and also the organic nitrogen is removed for 98%, and the total nitrogen for 60%, and that is quite high for a wetland and even for a technical wastewater treatment system, because well, these results are comparable to what you can reach in large scale wastewater treatment systems. Okay, besides an example from the Netherlands, I wanted to show you an example that we constructed in China. Well, we didn't actually construct it. It was our partner Deihua Aquatech in Suzhou. They constructed the system, and we did a design for this. This is a project where the water from a canal in Kunshan, it's one of the black channels that are very common in China, and they produce a lot of odor in summer because there is wastewater discharge in the channels. And we together with Deihua, we made a system where we can clean the channel water, and it's actually a sort of a wetland park. As you can see on the right hand picture, you can also put a lot of flowering plants on the systems to make it have a very nice appearance.
1 minute, Dion.
Okay, thank you. So the last slide I wanted to show you is about a new system that we have patented together with Naturally Wallace and our French partner Synthea. Most wetland systems work with a pre-treatment, septic tank, or some pre-settlement system. But especially if you go for larger systems, then these septic tanks can become very large. And also, if you pre-treat wastewater in a septic tank, which is an anaerobic system, it will produce methane. And methane is a very strong greenhouse gas, as most of you will know. So if you can skip the septic tank, that would be a very good idea. And that is what has been done in France for decades already. They had a raw wastewater treatment system where you bring the raw wastewater, including all the solids, on top of the wetland. And now, if you combine this concept with aeration, and that's what we did, then you get the system, the rhizosphere, which treats raw wastewater and is aerated. And in that way, you can again reduce the surface area that you need to back to 1 square meter per person. And the solids in the wastewater, they form a sludge layer on top of the wetland, which grows in the course of years and can be harvested after 10 to 12 years to as a form of compost that can be used as a fertilizer. Okay, that was my presentation. You find the contact details for Rietland and for our Chinese partner Dehua on this slide. It will be sent around to all the participants, I think, the slideshows, and I will put the contact details in the chat as well. Thank you.
Thank you very much, Dion. Thank you to all the presenters. It has been a series of very interesting presentations. I'll now invite all the presenters to join me for the roundtable. We are running a bit short of time, but I have two topics I would like to raise with all of you as soon as you are ready. Just please, all presenters, turn on your videos so you're ready to contribute with your very quick responses. The topic I would like to raise relates to the observations given during the webinar, that on one hand we have had a very impressive level of reaching a huge number of the rural population with water supply services, very impressive and ahead of time before the SDGs. But at the same time, there are in some rural areas challenges with maintaining the quality and service levels. And here comes the first questions, and that's particularly for those of you related to with digitalization. Given that we have to respond to this maintaining the quality levels, and given that it has to be cost effective for society, what do you think are the perspectives for the first round of answers will be dealing the perspectives related to digitalization, and the second round of answers will relate to nature-based solutions. You're ready. You're invited to chip in where you feel that you have some to contribute. But what can digitalization contribute? And in this context, what is the necessity of corresponding digitalized solutions at city or utility level, and then the system operated by the authorities, catchments, including lakes, and the overall monitoring system. So to get the very good translation here. So please chip in if you have a contribution here, and I'll invite you to do it in the order you appear on my screen. So Bruno first.
Okay, thanks, Henrik. But to put it very simply, I think my view is that the only purpose of digitalization is to address water quality, service levels, or efficiency needs, or whatever are the prioritized needs of the water utility. If it doesn't, there is no point. And I'm saying this, you might think it is common sense, but in the world we live in, we see a lot of companies, including smaller utilities, doing smart projects for the sake of it. And I think there's actually no point doing that. So this would be my answer to the first part of your question. The second part on the interaction between the water company, the utility, and the upper levels. What we see is from an O&M perspective. We see this. We have experience of this in two configurations. Maybe not exactly what you're saying, but in mainland China, we have a lot of clients which are part of a larger group company. And there's like a level of reporting between the site level system and the group level system, which may be from different supplier. So we are used to this type of interaction, kind of reporting interaction. But maybe you were referring more to authorities, and we have such experience in Hong Kong. So Hong Kong is not a small city, it's a big one, but there we have done a lot of where we work there at the utility level, typically at the plant level, and the government has quite strong regulatory requirements for automatic reporting of O&M, operation and maintenance information. So we deal with that, and through actually system interfaces. But then again, the system interface has to be designed to make sense and to serve a purpose. So this is just to say a few words about our own experience with this. I don't think we can develop further.
Thank you very much, Herbert Chan. What's your take on this?
Well, we have experience, with the smart energy project in northern part of China. So it's a very remote villages. So we help them to build up a, what do you call it, isolated heating system. I think according to our experience that most of the information or the real situation in the countryside, they are actually fragmented. So which means that people, they are not able to, they're not even aware of which information is valuable and what kind of information should be reported and should be recorded. So I think the purpose of this digitalization or all kinds of sensors is that to help those citizens or villagers that they don't even have a judgment to make sure which is important and which is not. And then we collect all the data to the central management system, and we have expert, we have all kinds of experts to help them to make the right decision. And on the other hand, that once you collect the data from remote areas, so as I said in the previous presentation, the digital asset is actually very critical for all the government to actually simulate or forecast what might be happening if something really happens. So I think I will stay with my previous saying that if the digitalization, they're not able to help the government or whoever is managing the system to make precaution judgments, then it doesn't really mean anything. It's not smart. Okay, that's my point.
Jing Ma, what's your take on the relation between technical solutions on site and the overall management and within a catchment level and to get the best value out of our investments here?
The project we are doing right now in the Fujian has actually showed the because actually our client has been just kind of outsourcing the traditional infrastructure department to the industrialization. So they are quite cautious when we present our solutions with this MBS. It's quite match what we all discuss about this. They are cautious about the efficiency of the waste collection system. They are quite cautious on the maintenance cost after it's made, because they want to reduce the maintenance as much as possible because they are working on their own. So they stopped to receiving the subsidy from government anymore. And then the third point is that they are really cautious on this cross sections design. So right now they have nothing. They don't have the flooding line. They don't have geological data. They don't have the geological survey. They don't have the flooding meteorological analysis. Nothing. So when we start with a project, we have to giving them how to solve the multi problems of the existing river and creek, and then in the same time they want the multi-function system after it's delivered. So both the water works, both the wastewater department, both the water resource department, these three departments, they really have to work together from the day one, from the planning perspective to the design perspective, and then after that they share the risk, who is paying for what. So for us, we can all say in these trends and also the demands for digitization and and low maintenance requirements from the beginning. Yeah.
Thank you very much, Jing. This leads me to pass on the question to Tia Savolainen. What's your take on circular economy in the water sector and digitalization?
Yes, thank you. I see, well, circular economy benefits greatly from digitalization, and I would suggest asset management as a management system to get the best benefit from the digitalization for circular economy. In short, thank you.
Thank you very much. Continuing the topic of digitalization, Luca Bovo, what do you see as the perspectives? How much can that contribute? You already covered some of this with your presentation of your equipment.
Yeah, thank you, Eric. Well, I will say what actually Mr. Herbert described a little bit earlier. It's actually the truth, of course, in China, but also all around the world. I can see, not a lot of digitalization, real-time data, or any data coming from the rural area or remote area. People generally start to focus, of course, makes also sense, but start focus on main city. For example, talking about sewage system, the main collector, then, they go down in smaller pipe and other areas of the countries. I will say, and I'm definitely agree, if you have data, you can control better, the situation in your city, in your network, but also you can find a little bit better against the climate change. As I was also discussing in my PowerPoint presentation. And of course, real-time data and accurate data can help people not only to improve the efficiencies, but also take better and fast decision, because you need to react really fast in some occasion.
Thank you very much. I'll pass on the floor to Fen. You presented your model for lakes. Digital twins at catchment level and real-time data in order to provide value for management and so on. What's your take on that?
I would say the cases of rural area and nature and the catchment level of management in China is very similar here in Denmark. In Denmark, we are lacking of human resources, but in rural China, we are lacking of knowledge. So there's huge knowledge gap between central government and the normal people. So you can build a very smart system, but the farmers will still secretly release their pollutants in the rivers. They throw their waste into the rivers. So the digital twin system, a running system, helped the government to monitoring the nature area, who is discharging, who is not obeying the laws. That's first. And second, I would say as international consultancy roles, we should really define what kind of roles we are playing, because I think here we are providing the technology such as open source softwares that will give the central government automatic solutions without license wars, without technology gaps. And here we have in Europe have 20, 30, even 50 years of experiences that we can share with the government. So I would say smart solutions, digital twins, open source softwares, and no technology gap, international knowledge provide services is very beneficial for Chinese market.
Thank you very much. Thank you very much, Fen. I will now invite Peder and Dion to give your take on the perspectives of nature-based solutions up against the challenges. And after that, I will ask to conclude the roundtable. And sorry for not having time enough. We could have spent hours on this. I'll ask Wu Xiaomei to provide your reflections on all the presentations you have heard. But first, Peder, a concluding remark on the perspective of nature-based solutions.
First, a little bit about utilization. Well, it doesn't give any meaning if you have a zero discharge facility to meter any water because there's nothing coming out. But I think there's no way out that we need to think in another way from now on, because if we don't do that, we will not reach the targets for the atmosphere content of carbon dioxide in the atmosphere. Also, we have to think very much about how we use resources, and one of the resources we can take out of wastewater is the nutrients, all nutrients actually, but especially phosphorus, which is running out in some few years. And potassium is it's a very easy way to take it out. And if we can even bind carbon dioxide or carbon into stems and leaves from trees, why don't we start doing that much more? It's said that these systems, they are too big, but if you use them in the right areas, they're absolutely not too big. That actually has to be as big as possible, because in that way you remove a lot of carbon dioxide.
Thank you very much. Dion, you will get the last word of the presenters.
Okay, thank you, Hendrik. Well, I can only agree with what Peder just said. Nature-based solutions are, I think, an important factor in reducing the CO2 footprint of wastewater treatment. If you look at the numbers compared to conventional technical wastewater treatment system in the large aerated systems, then an aerated wetland only uses 25% of the energy for the same amount of wastewater. And the more extensive types of wetlands, they only use 5 to 10% of the energy per cubic meters of wastewater treated. So that's a huge difference. Also, in terms of, well, what can you do with wetland? Of course, you cannot install a wetland for a city like Shanghai that would be require half the province of Shanghai maybe. So that's impossible. So wetland solutions are meant for the rural area, for smaller towns up to 50,000, 100,000 people. It's possible to work with a wetland solution. And then you can look at what the available area is. If there is a lot of area available, you can go for the more extensive systems that take up much space. But if there's less area available, you can go for the more intensified wetland systems, for instance, the aerated systems. Well, what's also important, I think, is what we are trying to do, for instance, in Kenya, but there are also areas affected in China by drought, is reuse of effluent. And we have found in a project we did in the Netherlands, in Terneuzen, that you can also use wetlands for post-treatment of wastewater coming from a conventional treatment plant, and then you can go to a next step, membrane filtration. And without this step of the wetland to membrane filtration, the system will clog. You will have a lot of biofouling on the membranes, so high maintenance costs. But if you include a wetland as a step in between of the treatment system and the membrane filtration, your costs for maintenance will be much lower, and also the energy costs. So that way you can reuse.
Thanks a lot, Dion. With this, I will invite Wu Xiaomei to give your reflections on the presentations you have heard. They have been a combination of digital solutions, small-scale infrastructure, customized to local circumstances, and nature-based solutions. So, Wu Xiaomei, please, what is your takeaway from this webinar? Wu Xiaomei, are you with us now? All right, it seems like we have not Wu Xiaomei with us. It could, of course, have been interesting to learn what her takeaway from all the presentations have been. But that will that points me to a couple of coming opportunities for continuing discussions. And first, very briefly, Liam Jia, you should have talked about the upcoming side event at Aquatech Shanghai, but you got some news here. Liam, please.
Yes, so very quickly, I would also share my screen. A small presentation that I prepared for this occasion. Different from the companies, we are here representing a EU-funded project that provides support for European small and medium-sized enterprises on market access to China. And we are also not only focusing on the water sector, but the general sectors as well. Very briefly about the projects, we have been founded already in 2010. We have a team based here in China, in Beijing, as well in Brussels. We provide services that includes market reports, guidelines, case studies, as well as free of charge advice, inquiry services, covering the legal sector, market access, HR related issues, and so on. We also provide face-to-face and online trainings and workshops on a matter of China-related business issues. As well, we provide SMEs with the advocacy platform. We voice on behalf of small and medium-sized companies operating in China to constantly improve their business environment. And our collaboration with the China-Europe Water Platform also dates back a few years. Including this webinar series. Most importantly, like Henrik has mentioned, we are going to participate this year again at the Aquatech in Shanghai. What we are offering here is our participation, but as well as other benefits that includes possibilities for participation at the booth at Aquatech. Participation to side events that we organize together with China-Europe Water Platform. We'll be able to provide you the opportunity to connect with professional audiences, as well as other exhibitors from China and all over the world. We'll also be providing you the chances for one-on-one advice on market access related issues with industry experts from us, from the USME Center. And eventually aiming at matching the technologies with the challenge owners and a series of follow-up activities in the second half of the year. And who should join us? As I mentioned in the beginning, we are a EU-funded project. We provide services primarily to small and medium-sized enterprises from Europe, of which many of the companies who has presented today are of course qualified as beneficiaries. We also provide this opportunity for industry associations, clusters, and business support organizations from Europe, as well as other EU initiatives that are supporting SME internationalization. Having said all that, one unfortunate news is that today I was informed by our colleagues, the organizers, at Aquatech Shanghai, that due to the current situation and the instability of the situation in Shanghai, the fair has been postponed to an unknown date, to a later stage. So we'll keep everyone informed, and of course through this webinar series and also through all the email communications of the USME Center and also of the China-Europe Water Platform. In the end, I leave our contacts information, and I'll also put this in the chat. And that's it from my side, Henrik. Back to you.
Thank you very much, Liam. And with this, I will give a very few concluding remarks from my side. First of all, thank you very much to all presenters. It has been a condensed but very interesting and fruitful webinar, which have given, at least me, a lot of food for thoughts about the challenges related to rural water management, to the challenges existing. And we will, of course, try to summarize all of that in the report which will be made about this webinar and circulated in a few days, together with link to the presentations given. As I said earlier, we could have been discussing these topics for several hours, but that is unfortunately not possible. And again, with the latest disturbance from the COVID-19, we have also now learned that the Aquatech Shanghai will be postponed. Eventually, it will be carried out, and that will be one of the places where we will offer a physical meeting, also allowing for all the discussion afterwards and relation building. There will be another opportunity, a WaterTech Expo organized by the Ministry of Water Resources in Nanchang, Jiangxi, on June 16th. And I will invite everybody who is interested in taking part and eventually also maybe giving a presentation to contact me afterwards in order to convey this to the organizers. and finally the IWA World Congress in Copenhagen. So we'll find various ways of continuing the discussions, and as said, unfortunately many times before, hoping to be able to meet in person as soon as possible. But once again, thank you to all the presenters. You've done a great job in staying within the timetable, and I hope that everybody who's participated have got good result out of joining. Our next webinar will be on May 24th, which will very much be on water quality monitoring and management. And here we will have chances of continuing discussions of today. So thank you very much to everybody. Have a continued nice day. Thank you. Bye-bye.
Bye-bye.
Thank you. Bye, Eric.
Bye bye.